So if you're a control engineer, you've probably heard all the hype about AI. But what does it actually mean for you on the factory floor? Well, in this explainer, we're going to cut right through all that noise and show you how AI can be a really powerful and, most importantly, safe tool, not something that's here to replace your expertise.
All right, let's just get the biggest myth out of the way right up front. This is not about letting some unpredictable algorithm take over your most critical control loops. No way. We're going to completely debunk that idea and show you where AI can bring massive value and do it safely and reliably.
And this quote right here, this is the heart of it, isn't it? In your world, guarantees and reliability are everything. A 95% success rate is just a 5% failure rate, and that's just, well, it's completely unacceptable when you've got physical assets and people's safety on the line. We get that, and that's our starting point for this whole conversation.
So let's dive right into that fundamental conflict. You know, the hype you hear versus the actual reality of process control. Why can't you just swap out a trusty PID controller for a big, large language model?
Okay, what's so interesting here is that you're looking at two totally different design philosophies. On one hand, you've got your PID controller. It's deterministic. You give it an input, you get the same output every single time. It operates in milliseconds with rock-solid mathematical guarantees. An LLM, on the other hand, it's probabilistic. It's an amazing engine for understanding language and finding patterns in mountains of data, but it is not a real-time feedback mechanism. You just can't have a controller that might give you a slightly different answer for the exact same input. That's a recipe for chaos in process control.
And this just nails it. An LLM is fantastic at fitting a curve to a huge amount of data to predict, say, the next word in a sentence. But it doesn't understand the physics or the control theory that guarantees stability. It simply lacks those foundational principles that your entire system is built on. So if AI isn't going to fly the plane, what is its role? Well, this is where we need to kind of reframe our thinking. It's not about replacement, it's about augmentation. Let's talk about this concept of the AI copilot.
The key phrase here is cognitive layer. The AI copilot is designed to handle the information overload, sifting through decades of maintenance logs, manuals, sensor data to give insights to you, the human expert. It automates the tedious work so you can focus on the critical judgments. The pilot is still in charge, they just have a much, much smarter assistant sitting next to them.
Now that all sounds good in theory, right? But how do we actually make it safe in practice? Well, it all comes down to the architecture. You don't just plug in AI. You have to build a framework of trust and control around it from the very beginning.
And thankfully, we're not starting from scratch here. Cybersecurity agencies like CISA have already laid out some really clear principles. It all starts with understanding the tech, then assessing the specific use case, establishing clear governance, and, this is the most important part, embedding safety and security into the design from day one. This isn't the Wild West. There's a formal, proven methodology.
And the absolute cornerstone of that safe design is this simple but incredibly powerful concept, human in the loop. We call it HIL. The rule is, no AI should ever be allowed to perform a critical, irreversible action without explicit approval from a qualified human. That one principle prevents pretty much every nightmare scenario you can think of.
And this is what that human-in-the-loop workflow actually looks like. It's a predictable, repeatable, and safe pattern. The AI gets a task, it comes up with a proposed action, and then it pauses. It stops and waits for a human to review the situation and give it a go or no-go. This design basically teaches the AI to ask for permission, not forgiveness. The human expert always has the final say.
Okay, so let's take all this out of the realm of theory and put it on the factory floor. What does this copilot actually look like when the pressure's on and things go wrong?
I mean, we've all been there, right? The pressure is on, every minute of downtime is costing thousands of dollars, and the one person with the knowledge to solve the problem might be at home, fast asleep. This is exactly where the old way of doing things starts to break down.
You know, a common fear is that the AI will hallucinate, that it'll just make up a plausible-sounding but totally wrong answer. But the solution isn't to hope the AI gets smarter. It's to make sure it never has to guess in the first place. You ground it in your plant's specific data, your manuals, your maintenance history, your expert notes. By giving it this augmented knowledge, you take away the need for it to invent anything.
So, back to our 3 a.m. scenario. The technician describes the problem in plain English. The AI copilot understands that.
It identifies the exact asset in your maintenance system, and then it instantly analyzes every piece of relevant data it has access to. It might find a similar issue from 5 years ago, pull the exact repair procedure from the OEM manual, and put it all together into a clear step-by-step guide delivered right to the technician's tablet. What was a crisis now becomes a structured, efficient repair.
So when you implement AI this way, as a human-centered copilot, the benefits go way beyond just fixing a machine faster. It really creates a new competitive edge for the entire operation.
So what does this all mean in practice? It means your engineers are freed up to actually solve new problems instead of just digging for old information. It means that priceless tribal knowledge from your most experienced experts gets captured and preserved instead of walking out the door when they retire. Your MTTR goes way down, your safety improves because the correct procedures are always available, and you basically make your top experts' knowledge accessible to everyone on the team 24/7.
So the real question isn't whether AI is coming to your plant. It's about how you're going to architect it. With a massive skills gap looming over the entire industry, the real risk isn't the technology itself, it's not having a strategy to capture your team's deep expertise before it's gone for good. The copilot is ready. The only question is, are you?